Yo, what's up, everybody? Welcome back. Today we are working on our neural network training framework again. We are kind of developing this thing with the intent of using it to train a neural network that we can run in our web browser that will parse barcodes for us eventually. Right now, we're kind of on the stage of trying to isolate barcodes, which is something that we have done by hand in the past, but it's something that we were trying to get a network to do as well. This should be a very easy problem, right? Right now, we just have a constant background and some barcodes. If I press play, we let this thing train for maybe 20, 30 seconds, and we're getting to the point soon where even in that short amount of time, he's starting to have something. You can at least see that he's tracking the images, at least, or the barcodes in the images at least a little bit. But what we are finding is I want to run many experiments to see what network trains something that is good enough for what I want it to do for the next step fast. And so there's a lot of things that we could parameterize to play with this. We could play around with the image generation itself. What's our input size? How many images are we going to feed to the thing to train at once? What are our learning rates? Our network, should it have more convolutions, less convolutions? Should it have more linear layers? What is our loss target? Are we trying to predict center and width and height and rotation independently? Are we trying to predict IOU and then trying to backprop that? There's all sorts of experiments that we want to run, and there are multiple things that we need out of the experiments. One, we need to be able to see, we need some stats on, as we run many experiments, which thing did best, and we also probably want to be able to look at the results of them in the future afterwards as well, and schedule many things to run overnight. So that's kind of the headspace we're in right now. So I think today's topic is going to be about stat collection and comparison, right? So I want to know, as I change things, did I train faster and get the same results? Did I train faster but get worse results? And so I want to I need graphs and stuff to inspect that data and make good decisions. So that's kind of the aspect of this problem that we're going to be tackling today. And so I think it's basically let's export some data as we train. Let's figure out what we want to export, then export it, and then make some visualizer that can compare things, right? Yeah, so that's the plan. I don't really know what this is going to look like. We have some ideas of things that we want to do. We're going to want to be look at graphs of loss of one thing versus another, but maybe loss is not a good answer, because if we're changing the loss format, then those aren't one-to-one. So maybe we need some sort of external metric that is calculated on some validation set every once in a while. But we probably also do want to look at loss over time as well. Yeah, so I guess the question is, what do we want to look at? I'm imagining that we have a graph, and we see as we train something, he gets better over time, and eventually he starts getting better slower, right? And what we want to see is, if we train a second guy with different parameters, we want to see, does he kind of look more like this? Does he look more like this? Maybe he looks more like this, and we want to be able to compare these things. X-axis here is interesting, right? X-axis, we probably want, maybe we want to look at this thing in terms of iterations. Maybe we want to look at these things in terms of wall time. Maybe we want to look at this thing in terms of number of images processed, right? These are all things that I think are interesting for x-axis. And then y-axis, what might we want? We might want loss is the obvious, that's the only number we have right now. Maybe some sort of normalized mean squared error in some way, maybe something custom, right? And maybe the elements that this is working over is, maybe it's a validation set, which would run every 100 steps, we take a look at this validation set and we write down stats for that thing. But maybe we're also writing down the loss every step normally. Maybe we're writing down the loss every 10 steps and validation every 100 steps. There's stuff like this, where we're going to have, I think, in the context of bounding boxes, we might want to look at, what's our center offset and our width offset and our height offset. How wrong are we on each of these individual components? We might want to look at, if sometimes we're really wrong, are we covering like 99% of these things very well and only 1% is a problem? Like, what is our like 99 percentile accuracy versus other models is like something we want to look at. So all of it to say that there are going to be custom statistics that we are going to be collecting. And we are going to be collecting that at probably uneven intervals. And so we need some data format where we can say, hey, here is some stuff I did. Let me put that in a file, and whoever is looking at this thing later can choose how to filter that data. I think that's the key here. And so the question is what is the format of that data? Okay, so the obvious thing here is like a CSV, right? But the problem with CSV is that you have like kind of fixed columns that everything has to conform to, which it might not be nice for our like multi-typed data. But there is something nice about a CSV where it's easy to look at. Multiple CSVs is another option, except then you don't get like the sequence as well, right? So if you're trying to like glance at the data in the file, I would like the file to be human interpretable. I would like for all the data to go into one file. So maybe the only thing we need is if we do a CSV where the first column is type. JSON stream, I don't really like. It just feels like JSON is like the wrong format here. Honestly, like a database is like not crazy. Like an SQLite database doesn't feel that bad. But I think like a CSV here would be like where the first column is type and then like data. And that would let you do something like you could grep the log for your type. And that would give you like a nice little sequence of things that happen for the thing you're looking at. Okay. And maybe you could actually just do CSV. You could just do like key value. Maybe. Yeah, so if everything is key value, then because like is everything we're graphing key value? Probably, right? Everything that we've talked about so far is like we have some x-axis and some y-axis. So what if we do for now you do something that's like imagine a file where we have every line starts with what it's updating. So he's starting with, this guy says, I am updating iteration. We are now on iteration 100. And wall time for iteration 100 is, 10 seconds. And what was the other thing that we might want? Like, num images here is now like, we've processed 1,000 iterations or something. Or 1,000 images, because there's like 100 per, or 10 per iteration or something. Then we come in and we have like stats, right? So we have loss here is like 100 or something, right? And then this happens a few times where we have like iteration of 101 happens at 10.1 and num images is 1,000 or like what this would be like 110 and our loss has gone down to 99 or something. And this happens a few times. This is pretty noisy. This is pretty noisy in terms of like we're not really getting much information density here. It feels like it's not that dense. But this does allow us to do something where every once in a while we have like validation stats where we have like, okay, so center offset, 90th percentile is this, and center Y offset 90th percentile is this. And like every once in a while you have like a batch of validation stats with any sets of keys, right? That's kind of where this is going. I like the idea of maybe instead of iter wall time and images, we might just have like step. And in here, we kind of fold all those guys down. 101, 10.1, 1010, right? This is like a little bit more dense, I feel like. Not very dense can be solved by piping through a ZSDD. Yeah, but I'm thinking like I want density in terms of like how I can look at it. I'm also not the biggest fan of this type of thing though, because these, as the numbers grow, like get hard to look at. I guess you could pipe this into Excel or something, and you get like columns. You could also probably run something like this through. I think that there's some program that lets you uh like format this type of stuff. Log dot CSV or something. I think there's some program that lets you visualize this stuff in the terminal a little better, right? So we can do like, is it like bash program make make like tab CSV or something? I want to like visualize bash cat CSV nicely. You guys are just saying column. Cat log CSV column. It's not really what I was looking at, unless there's a way to specify separator. Yeah, maybe column dash s comma. I don't really know what this is doing. Yeah, I'm sure that there's a way we could do this. Pretty sure. Column dash s. Oh wait, hold on. These guys are doing what you said. Oh, okay. Yeah. That is what I was looking for. Okay, sure. So this isn't crazy. This isn't crazy. So here we could grep for step and whatever field we care about, and we could like inspect this okay. Yeah, I think this is okay for like a version 1. It could be better, for sure. There's like reasons why this is not good. But this, we have to pick something, and this is good enough for now. So let's start exporting some stuff, and then we can start playing around. So whose job is it to do this? Probably like our train thread. Maybe ideally the train thread doesn't do any IO, so he's spending most of his time actually training. But that's okay. That's okay. We can cover that later. So for now, can we just write down loss? So let's say we have. Are we keeping track of our like number of iterations right now? I doubt it. Iter, we'll keep track of this. We keep track of wall time is stood time instant now. Okay. And here we can say every time we do this, we say iter, maybe we just do this at the end. Iter is increased by 1. I guess if we do the IO while we're waiting for the GPU to finish, then it's actually not the end of the world. Yeah, but I guess that also means that you need fuck it. It's okay. We'll get better later if we need to. Okay, so we increase iter by 1. Wall time, I guess this is like start time here instead, actually. And our wall time is stood time instant now. Since we started. Okay, and then we do something with this stuff, right? So we probably have some file, log file. I guess we'll call this like yeah, log file, I guess. Current working directory, open file, and we probably want this to be relative to some training directory. Probably. So maybe when we launch, we say, hey, could we have like outdir or something? And this output dir will say, hey, if you see outdir, please try to parse this thing. And we'll say missing outdir arg. This probably has to get added to the help as well. Outdir, this is where to save training data. And we should also have a network config in here, but whatever. We'll cover that later. Okay. This is like this. Okay, this is required argument. Cool. And so I guess off rip, we will try to open this thing. Is there like create, like make dir? And is there like make path? I think one of these return success if the path already exists and is a directory. Nice. So here we can be like args outdir. I guess we actually don't want it. If it already exists, we're probably in trouble, right? So we'll kind of do it like this. And then we can pass the outdir to the training thread. Okay, and then this training thread can go hit me with that outdir. I guess technically we should close this thing later. And now this guy, when he creates the log file, can be like outdir create file, and we'll call this log CSV. Wow, look at us go. Okay. Log writer is log file writer. And now we can just be like log writer print I think if it's a buffered writer, then we can flush the last iterations here or something. Const buff writer is like stood io buffered writer log file writer. Okay, here we go. So we'll just flush this every once in a while. And then, later we should, ideally this goes on to another thread or something, but like, fuck it, whatever. Log writer print, so it's like step is the type, and we then pass in the iteration, the wall time, and the number of images. So this is iter, wall time, and iter times config batch size. Cool. And then here, I guess we just do this, right? And then somewhere we need like loss. And we should probably only do this like every once in a while, right? So if iter percent config log frequency maybe is equal to 0, that's when we do this stuff. Because now we can do kind of like more expensive stuff like calculate the loss. And we have somewhere where we're already kind of like doing that. But it's not super obvious. So here we'll just go like total loss, I guess. So total, so we have like loss to self math executor to CPU loss. Is loss a trace tensor? Yeah, it is. Like this, loss CPU, and then we say var total loss equals 0 for 0 to loss, for a lost CPU item, we get a total loss plus plus L, and then we print the total loss here. Okay, cool. So every once in a while we do this shit. Sure. And so now our config file needs a log frequency, which means that this guy outputs 1, and we'll say every 10 iterations for now. All right, let's see what happens. He's mad because what? Okay. This thing is never edited. True. This is double tried for some fucking reason. What the fuck? Whoa. Opened. Fine. Args. I don't give a fuck, probably. Throwing away 9% of data? Hell yeah. Hell yeah, you can't stop me. Try here, probably? No. Wait, the ones he probably, what's he pissed about? Oh, var here, I see. And then this guy, I put the ampersand in the wrong spot because I wasn't paying attention. Lost CPU here is not iterable because this thing could fail. All right. Outdir is outdir not provided. We should be correct with our error messages. Okay. Outdir is train output. Okay. So now we should see. We need to do a defer buffwriter flush. And defer log file close here, probably, right? Okay, and then here, I think that this will fail because train output already exists, so we can arm just our train output. And zig build, and zig out, bin smelly, all this stuff. Okay, so this has run many iterations already. So we should be able to go into train output and look at this thing. Cool. Looking good. So now we have our stats that we need, and we can like try to make some sort of visualizer. Eventually, I think what we do is we come for a visualizer now, and then we like loop back for like other data. We might want like a schema for this thing, but maybe we can also just kind of parse the whole file up front if the data is if the log's like small enough, then we can kind of get away with just kind of like doing it all at once, like just rip the file one time collect all the data that we care about and then like graph it how we want to graph it. I think that's fair. I think that's fair. Okay, so we need a program. Can we copy paste our GUI demo? Let's start here. So can we paste this as visualizer? We should be careful with our names here. Visualizer is a bad name. So can we do this like in like train output viz zig or something? That's good enough for now. And we will compile this thing. So we have oopsies. Train output viz is train output viz with train output viz. And let's compile this thing, or let's install this thing, put it in our build output. Let's just kind of see where this goes. I think that we need to adjust some of our imports there. Yeah. This guy needs a little bit of love. So this comes from stud is our standard library. This guy is stud alloc. This is stud render. This is stud window. This is stud GUI. But everything else, I think, just kind of works. No? Oh, fuck. I added the wrong guy. There we go. All right. All right, here is our example thing. So now, I guess we just have to start like doing stuff we want to do in here. So let's start by parsing our file. Oh, like parse data. So this is going to come from some path. And he's going to return data. What does data look like? So we have our kind of like, we have like our step thing, right? And this is like predetermined as having many pieces to it, right? He has the iter. He has the time step. And I think this is in nanoseconds. I think. So this is a U64 probably. And then he has what was the other thing? Images. Okay. So our data is going to have like x's. And at, ooh, this is interesting. I think that we kind of want this. I guess at each x, you could have which pieces of data you have. Yeah. So maybe this is kind of like this. So we have a bunch of elms where elm is like key val. And then maybe this should be more like as a U size, and we should have keys here. Right, so we have like a list of keys somewhere that we keep an eye on. Then we look by key, and then value becomes a floating point number, probably. Yeah. That seems pretty reasonable, right? So then we have like our parse thing. He's got steps is this, right? And so when we parse this thing, we're going to have a bunch of steps that have loss in here. And so I guess we just have to start parsing the data. Open file at path with this. What are we going to do here? We're going to be like F reader, probably. Do we just want to read this thing to a file for now? I feel like that's easier. I know that like IO reader is like an interface we can use for this. Well, we can see. Reader, read until. I mean, also, this is all going to be fucked. Right? Like when I upgrade to Zig 015, all of this will have to be rewritten. But whatever, it's fine. Tony's up, but don't usually have no music. I decided that I don't mind it. I don't mind it. Okay, so we'll like read a line, I guess, and then we will say key is line read or like stud mem. I guess we have like stud mem here, iterator, split scalar. Yeah. And here we're looking at the line and we're looking to split at commas. I'm just creating a small project to 15. It's not fun. LOL. Yeah, I've been like putting it off, but I know it'll be worth it. I just, it's not the first thing on my mind right now. Okay, so I guess here it's like, we have the type here, and here we're gonna be like, surely this isn't a loop. And here I guess it's like, surely this exits somehow. So if this guy reads until delimiter, deprecated, use stream until delimiter. Okay. Reads from, well, I'm just not going to do that actually. Okay, so, or EOF. Wait, hold on. Nice. Nice. Okay, so if this thing returns nothing, or else break. Easy. Come on, come on. Cool, so now we have like a line type here, and stud mem equal, if the line type is step, then we do one thing. Otherwise, we do something else. Okay, so if it's step, we are trying to parse 3 values. So we just keep going. So we just go, iter is this. We have time ns is this, and image is this, or else return error, invalid data, bing, bang, boom, right? Easy peasy. And then I guess this is all in string land, right? So we need to go like, we have some data here where this is going somewhere. So I guess we have like a step that we're building right now. Var step is a, an undefined step, I guess. I guess this is like line by line. So we kind of have like a step here. And maybe it's like, I wonder if it's like a step builder or something, right? Who has like his, this stuff is guaranteed to exist, I think. And then this, I guess it's like, do we have an existing step? And this thing starts as null. That's what it is. And then I do kind of feel like this guy gets a like growable list of some form. Don't really know where this is going yet, but whatever. Maybe it's just easier for this stuff to kind of like we'll say like next maybe this lives here. Next X or something. Next step. And then here we hold like a next step. And maybe we just parse this thing off rip. So we should do like parse line. Maybe it comes out into a function that returns, or we could have like parse step. Yeah. Yeah. It feels like it's something like this, right? So this is like, let me do all this stuff where I like read, maybe we do it off a line or something. Maybe? I don't know yet. We'll see. We'll see. Okay, so we like parse the line or else return error, no data. And then we say like step is parse step of this line. Yup. And if this so we get the, we do this. Boom. Here we go. Okay. So if we have these things, then we can just we go, if this is not a step, then we have like a fucking problem. Return error not step. Okay. Then we can do this, and we can return here. Iter is equal to iter s, you know, try stood format parse int. We got time ns is parsing u64, and then image s is usize. Okay, here we go. That looks like something. That looks like something. So now off rip, we say, you know, var step is a next step of something. He's never null now, which is kind of nice. Right? Cool. So now we have this thing, and now we go line by line, and if we see a step, we say step is equal to parse step of the line. But before we do this, we like commit previous data, right? So somewhere we have keys needs to live somewhere. So can we go var keys is you know, some list of strings. Do I want this to be like this? I'm thinking. So we're eventually, I guess it just makes sense for these guys to just come out this way. That just makes our lives easier. Yeah, that's just easier if this is like this. If everything is runtime segmented lists, then we're like not really over allocating that by that much anywhere. We can use a linear allocator without any problems. Yeah, so fuck it. Fuck it. That's great. We get to define how we want our data to be stored. Okay, we have some like alloc here. Okay. And I guess we initialize this with alloc, and we have some like bounds that we can set here. So this guy is saying, what is our like minimum size of this thing? Like 10, maybe 16, so it's a power 2. And then our max size is like, how many keys could we like ever fucking support? Like, that's a lot, you know? That's fine. We got keys coming out of this thing. Whoa, this is the wrong spot. My bad. My bad. This is supposed to go here. Okay. So we got keys. We got steps here. So what is like, what is our like expected number of steps? It's probably on the order of like less than like 100 would be a bit of surprise, and more than like 1,000,000 would also be a bit of a surprise. Probably. I think that's reasonable. And then is there anything else we're exporting here? Keys, steps, and then we have like elms. So steps here, this is of step. This is of elem. And how many elements are we expecting per step? Probably on the order of like 10 would be expected. Probably like 1,000 would be like insane. Right? That feels right to me. Okay, so if we don't see step, then we are expecting to do some sort of like key value thing. I think that we also we kind of want like a hash map for key lookup, huh? Probably. Uh stood string array string hash map unmanaged, I think, is the new way. I don't really want to do it like this though. That's fine. That's fine. So we have string hash map unmanaged, and he is mapping to indexes into the key list. I guess it's yeah. Yeah, it's like it's probably something like this. And here, I guess that kind of means that we want like a scratch allocator here. To be honest, I think that makes most sense. So now we can put, we can put the key lookup on the scratch allocator, and then everything else goes on the output allocator, which makes sense. Okay, so here we're like, can we just parse an LM? So this is literally just like, hit me with the key, val, and here we're like, key is key. But okay, we'll do this. KV, we'll call it, which is a bad name, but we'll live with it for now. Or we could do it this way. He gets passed in the lookup. Yeah, that's the easiest. That's easier. Key lookup is he needs like keys and the key lookup, I guess. and key lookup. Ew. Yep. Okay. So now he goes like, let me look that shit up. So we have the key. And I guess that means that he needs like key lookup alloc. Gross. This is why I don't like the I'm not a big fan of the new um force to unmanaged interface. I'm not honestly like the biggest fan, but whatever. Because like tracking your my allocators becomes like a lot harder this way. But what is what it is. If gop hello? If found existing. I guess if we didn't find existing, we say keys append the key. Now this key needs to be cloned, so now we have like keys alloc here. Gross. Keys alloc dupe key. Yes. Okay. Easy. Easy. And then we say gop value pointer is keys len -1. I guess len before, len -1 after. Because for error stability, that's a little better. Okay, val. So this is gop key pointer here. Nope, value pointer, my bad. Then our value is try stood mem. Format parse float from val s. Okay, cool. So if we don't see this thing, we call parse elem with line. Okay. With keys alloc key lookup scratch allocator. Okay. And then we say so like elems append the elem we got. Okay, easy. Wait, this is looking, it's starting to shape up. This is starting to look like something. Okay, so here we say steps append. You know what? I'm kind of down for elems to start. Oh, that's fine. It's like 10 element is a lot of overhead if there's like a lot of things and we only ever have like 2. So maybe like 2 here is like a more reasonable guess. I don't know. Maybe even 0, to be honest. Just so it like picks the first block. Oh no, 2. 10. Whatever, we'll leave it 10 for now. Okay, so steps append. What is steps? Steps is a bunch of step, which is these guys, right? So here we're like, okay, we will say that the iter is step iter. We have going to sleep. See ya. Image is image, right? Time is time. Easy peasy. And then we inject elems here, which is the elems that we've parsed so far. And then we have to reset elems. So elems, I guess we do this. Min elems is 10. Max elems is 1,000. Then we have min elems here and max elems here. And then we can reinitialize this guy with a new bad boy. Boom. Okay. then it should be as simple as at the end of this loop, we do one last of these. Fix me, copy paste from above. Might want some, builder struct or something, whatever. And then, actually, we don't need to do this. So, which actually means this is fine. And then we should just be able to return a thing now. So what is our return type here? It's data. What does data return? What does data look like? Keys and steps. So here we're just like, keys is keys, and steps is steps. That feels like it might work. Data is try parse data, given the allocator we want to go out on. So maybe we'll do like, allocators root arena. Then we have the scratch allocator. Okay. Then we have path. So where's our data right now? Train output. Where is it? Hello? Did we remove it? Oh, we did. We did. So you have to be careful about that. Yeah. Okay. So we have this data, and can we go like for data steps? Can we just start looking at it? Var step iterator is data steps. Iter while step iterator next. We have some item or step, I guess. And can we like print the step? Let's just start there. Oh, okay. This thing probably doesn't compile right now. That's so true, because we fucked up all sorts of stuff. So this guy is like, or else return error no line. No content or something, maybe. This guy's like, no field name images, true. This guy's mad because, or else return error empty line or something. This guy's mad because expected this, found a pointer. Yeah, I mean, that should be a pointer. We're crazy for not making one. There you go. Key here is maybe there, not here. Error, no key. Or else return error, no val. Okay. Where else are we going here? Key is mad here because, really? Oh, because this is returning an elem. My bad. Elem. Boom. This guy is mad because we need to say what type of float it is. So true. All right. So now we have something. Let them run for a bit. Cool. Move train output back, like saved. And then can we parse this data from test output? Was it? It's train output saved? Yeah, there we go. All right. Let's see what happens. Okay, so good news. It looks like he did parse steps that are semi-valid. So we have one element per thing. That's really great. So can we go for each step can we print maybe the image, time, and, you know, time and image that we're on, and then we go for var like key value iterator is step dot elms iter while kv iter next. We have some kv, and can we print out maybe like an indent with the key name to the value? I think is a good place to start here. So this is going to be data keys at kv key or something, which he doesn't seem to like. Elms is an elm. Elm has keys. That should be fine. I don't know why he's not highlighting. And then this should be the value, which is kv val. Am I high? Okay, I was right. Highlighter was wrong. Okay, I mean, that looks pretty good, right? So here we're seeing that we have loss logged each of these things. And can we now just huck in, you know, an extra thing just to prove to ourselves that we could do something that we wanted? So let's say we say every 50 iterators or every 50 iterations or something, we throw an extra thing in there. So if I guess we like this. If iter percent this times 3. So if we're on every third log, we'll throw in a like lol hello of 0. Just to prove to ourselves that this is what we want. Give it a sec. Run a little bit. God, what am I fucking doing? Say rm.r train output saved, and then move this again, and then run this. Okay. Yeah, so okay, we are seeing lol hello every time here, which seems bad. He is logging every time. Probably order of operations here. Should play that animation sound during training, yeah. Alright. Move, and then can we take a peek here? There we go, okay. So now we see LOL hello every once in a while. So first try on parsing, that's not bad. That's not bad, come on. I mean, I know it's easy, but that's not bad. It's not bad. Okay, so now we have to like visualize. So I guess we were kind of like parse here. And let's say that we are on visualizer visualize. Okay, so what do we want to do here? We probably want like a generic OpenGL graph widget, right? That just draws like a line graph based off of some info. So like, what does that look like? We probably just do like GL line of thing. Well, this is going to be like a more advanced widget than that, right? He's not just showing one line. He's going to be showing, eventually, we're going to be comparing many lines at once. So maybe this is a custom widget for now, and then maybe we find something that's like generic out of here. But for now, we will just say that we have some sort of custom widget for this thing. So we'll call this a like graph widget. And he has to conform to the widget API. So he's going to have some vtable that is from like GUI widget vtable. Okay. And what does this guy want us to implement? He wants us to implement these. So we won't implement any of the optional ones for now. boom, 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 and we will implement these. So this is like, this is this. Oops. That's fine. It's fine. Okay. GPU already makes noise during training. If your headphones aren't poisoning with the GPU coil whine during training, you're not training hard enough. Dude, with my new motherboard, my headphones don't just make noise if nothing's playing. I used to have to like play something at 0 volume to stop my headphones from crackling all the time, because like there was something there where it's like if it wasn't active, it would just pick up noise from the world, which is pretty funny. But now we're good. So exciting. Okay. So render, like, these are like functions that will do something at some point. I don't know what yet or anything, so we're just gonna like stub them out for now. This guy is surely going to be like, I'm going to take my graph widget and update the size to fill the available space. That's kind of where we usually end up with these. Render is going to do nothing for now. We're not going to render anything. We will eventually have to render something, but for now, we can get away without it. And get size will return the stash size. So const self is a graph widget, which is pointer cast align cast of context. Return self size, easy peasy. And we will just stash the size as the available size every frame and ignore delta S. We don't give a shit about that right now. No animations to worry about. Okay. My speakers do that. I worked out if I have the audio settings page open, it stops it. Yeah, so you've got the same thing then. It's like you have to like make the chip that drives audio active. It tells you what your computer's thinking. Yeah, so true. Okay. Cool. So that solves some of our stuff here. So we should be able to make this graph widget, and we should be able to like see that it exists. So we should be able to go like, var graph widget is a graph widget. And this thing, I guess we will just default initialize. And then we need a like function to turn him into a widget. So this returns a GUI widget, GUI action, referencing himself. And he's like, okay, my vtable is vtable. Look at me go. And my context is self. Bang, bang, boom. So now we should be able to put this thing into the layout. So this should be like graph widget, bang, bang, boom. And what's he pissed about? Name is equal to graph. All right. Okay, so we have no proof anything is happening here, but I promise there's something here. Well, I don't promise, but I think it's likely. Nothing's crashing, which is really the big win here. Okay, so can we now do something in render to like make something happen? So we want to, what? We're gonna do, I think it's just solid color renderer, call render lines with some buffer that is sourced from somewhere. So I think that we can first prove that this thing exists by getting a solid color renderer. Solid color program, my bad. And we should be able to be like, okay, let's on render, just render a blue box for now. I guess we'll just render lines. Render line loop. Is there a line strip? I think there is a render line strip, which isn't hooked up, but we can have it. That's easy. Strip. strip, then s loop strip. Okay. And so now we should be able to call render line strip with some data. Okay. Render source. I don't know where we're going with this yet. And here he needs to set the color. So let's do blue, and transform is going to be like widget to clip transform given the widget bounds and the window bounds. Something like this. Okay, we're getting somewhere. This guy's mad because we need to set the solid color renderer. And I think that this is something that we have to make ourselves. Which is annoying, but whatever. Init. Oh, we have a fragment shader that... oh, it's a solid color program. No, it's fine. Do we have like a GUI allocator? Yeah, we do. I think it's like something like this. Okay, we need a render source here. So this is XYT program render source, easy. Which means that we need to make that thing. So we need like graph buff is some buffer initialized with probably a new allocator. This stuff is, oh no, this is gonna live for the lifetime of the widget. That's fine. So I think we can just use this guy here. And graph render source is a render source, easy. And so we put these here. Render buff is graph buff, okay. This is getting somewhere. Then this thing needs to be a buffer. Good day, how's the air quality? Hope it's clearing up with there. I haven't noticed any problems, but I'm kind of a fucking idiot, so... you know. It does look kind of brown outside, so I don't think it's very good. This thing can't fail, right? I don't know what the fuck I'm doing. Okay. Okay, so here we need to have a function on here to be like, every iteration, we must be trying to... Let me think for a second. So this guy's gonna like source some data from somewhere. Right, we're gonna tell him, get your data from here. How does our like histogram do it? When he has like, he must have some sort of like getter here. He has like a retriever, and does he like do retriever with generation or something? No. He's kind of... Oh, I see. So the retriever has a generation number on it, and then we determine if there's new data. I guess in our scenario, we kind of are processing all of the data up front, so we can kind of just construct these buffers up front as well, to be honest. That's not crazy. Okay. So let's say that we want to build a graph of, you know, we have, you had a histogram widget this whole time? Yeah, but it's like kind of different. And we made it recently, so it's like, it's kind of different, it's fine. I think this will be different enough. Okay, so this guy, we're going to like look over our data. And we're going to... What? Like, per key, we want to inject something here. I guess also like if we change the x-axis view, we'll probably regenerate the graph, right? I guess no, because every x point for everything is the same. It's just like which thing we're visualizing is different. So that's fine as well. So we should just be able to like generate this graph off rip here. So let's say that we're looking at loss right now. We'll just kind of hard code that. Which will be the first key. We just know that because of the way we parse the data. Eventually we'll have to do something a little bit more intelligent there, but it's fine. So we need to like construct this buffer with that. So we want to probably there's some function that's like make like GL buffer from data key, right? Where we pass in like data and loss. Or maybe key like 0. Yeah, maybe the index here is going to make more sense because later we're going to be generating many graph widgets where we're going to iterate over the keys and make one out of each. Yeah, okay. Cool. So I guess it's kind of like this. Probably we're going to have some of this as well. And then we're going to make this function up here. And he's going to return what? A like friender XYT program buffer or something. This is GL alloc, which is going to be one of these. Data is a data, and this is index, key index, like this. Okay. So first, we have to rip the data once. So maybe we're going to have like a count key elms. No, I guess we have like a scratch allocator here. And we say here we have like checkpoint is scratch checkpoint, defer scratch restore checkpoint. And I think that we just make runtime bounded array on this thing, and we'll just pick like a sane size. So we'll say use scratch allocator, and let's say that you can have maximum like 10,000 things. And if we overallocate here, like get fucked. This thing probably has to be of type XYT program vertex, I think is how this works. So we're making a bunch of like OpenGL vertices here. So we'll say like CPU data, and we're gonna iterate over something. Data steps iter while step it next. We're gonna do something. So we're gonna have like I guess we like calculate the x position here in OpenGL space. So this is gonna be like var x index is 0. And I guess our x position is like as f32 float from int of x index over as f32 float from int however many like steps there were in the whole thing, right? Something like that. Oh, I guess data steps len is a really good target here as well. We can't have more than this many things. In fact, we are going to have exactly this many things, right? No, we're not. In some cases, there might be don't data for this type, so we can skip that one. Okay. Here we go. So this is normalized x. So we need to turn it to OpenGL space, so times 2 minus 1 to get us from -1 and 1. And I guess our GLY here, maybe we just use its value and we scale it. Yeah, we either have to like scale. We either have to scale now or later. But I guess like if on our first pass of the data, we could have maxes here. Where's keys? Maxes. Yeah. And so then we can compare to that. We can scale everything according to that. Yeah. So we can go like here we have maxes match this thing in terms of shape. And here we're like if lm.key maxes. I guess like while maxes len is less than lm key, we append a 0. And then this is like max pointer is this, and we like set this guy to the maximum of his existing value and lm val. Easy. Do we need to do the same for mins as well? Eventually, but we'll just ignore that for now. And of course, for you guys watching and you're like, wow, this code quality's shit. I know. It's supposed like we'll clean it up later, okay? Jeez. Nobody actually said that, but I have to guard against it, you know? Okay, so this is now like data maxes get step. Whoa. Oh, I see. So like if step var elm iter is step elms. Here we go. While elm iter next, we have an elm. And this is where we say if elm key is equal to key index, then we push this into the thing. So this is going to be lm val out of lm data maxes at lm key. Nice. This shit is so ass. It's ass like butt. Yeah. Now we can do this where we have some data to append here. And it's like v pause equal to glx gly or something. GLAlk is not used here because at the end of this thing we need to go like like a render xyt program buffer init GLAlk from CPU data items. And then this should be what we return, I think. So now we should have like some sort of buffer. We can say graph render source bind this data. So we're going to be using the solid color renderer to make this thing. And we're going to be using the graph buffer as our backing data store for this thing. This goes like this. And then maxes here, we need to pass along. All right. Sure. This guy's missing some arguments. We're missing allocators, scratch linear. Okay. Why is it? Well, why is this scratch? Because he's using it for CPU data. True. Okay, this guy's mad because we didn't write try over here. So true. This guy needs a try. Probably no. Var here, I guess, is what he's mad about. All right. Oh, come the fuck on, man. Let's fucking go. Wait, that's actually right. I was not expecting that to work first try. Dude, that's 2 mega first tries today. Look at that shit, dude. Look at that. That's a fucking graph, dude. If I've ever seen one. Okay. Bell curve for the win. Yeah, I guess we can remove that bell curve. That's kind of like just in our demo app, we have one of those, but we don't need it. All right. Cool. Cool. I mean, it's also really dark. Can we brighten that up a little bit just for, not that it matters, but let's get a little brighter up. And then I also want it to be wider, to be honest. So we just like GL pixel, GL line width. Something like this for now. There we go. Okay. So what is next? So this is kind of like visualizer graph widget, like graph loss. And then can we tack on maybe like a hover thing? Hover. Okay, so we want it so that we figure out where the mouse is on this screen. Why is the mouse tiny in this? What the fuck? Why is it shrinking? How strange. But we probably want to show like a dot on like the Y position where the mouse is, right? And then we want to be able to like extract the value from that thing. So really, it's cold. I almost didn't get it. So that means that like this guy needs a way to query the underlying data for this guy's value. So like what's like the convenient way to get that? I guess we like snap to maybe like the previous thing. Yeah, we could round, or we could just snap backwards to the last point on this graph that's valid. So we could store those points, or we just like we like look at the data and then just walk backwards until we find the one we care about. Yeah, I think that's the play. So this guy holds his like a key index here, and then also like the data pointer, right? And what he does is when the mouse is over this thing, we figure something out. I don't know what yet. I don't know what yet. But like it's so we probably like look at ourselves and we start by like figuring out what our X position is in widget space, probably. So we have like mouse pause here. If input bounds contains mouse pause, we want to do something. I guess maybe if it doesn't contain, we just like return. Maybe we have to like clear some hover state or something. And then we like take this guy minus widget bounds like left. Okay. Mouse pause x i32 is int from float of mouse input state mouse pause x. Okay. So now we can work in i32 world everywhere. Maybe we actually want to be working in float world though. Widget left f32. I think that makes more sense. I think. So we have like mouse offs is input state mouse pause x minus widget left type, and we want to convert this into this is in pixels, so we want this like over widget bounds calc width probably as an f32. So this is like mouse offs normalize. This is pixel space, and this is equals mouse off pixel divided by that. Cool. So we have like our mouse offset and normalized space. We want to multiply this by the like data size, right? The number of steps. So can we do float from int here, and then this is going to be step index. Mouse step index is this. Ew, disgusting casting. Just kind of like overall. Ew, nasty casting in general. But whatever. And then what we're going to do here, it's like while like var check like iterator, I guess, is mouse step index. Can we do iterating backwards on these segmented lists? I think no. So this is a little bit wasteful, but it's fine. While it is greater than 0, because it can't be less than 0, which means we add 1 here, so that we immediately subtract 1 here, and then we look at it. It's like a self data steps steps at iterator, and then we have elem iterator is step elem's iterator, and then while elem, we like look over these things. If elem key is equal to our key index, this is what we want to show. So we'll just write here, loss is this at this position for now. Right, let's just kind of see where this ends up. Data is data. What language? This is Zig. Key index is 0. And then, does this like work? I think we forgot to assign the set input state to our vtable. So just nothing's happening there. This guy's mad because contains. Oh. Better. Return empty, and we probably have to return empty no matter what. No action to do, please. We are doing nothing for now. All right. What the fuck is going? Oh, I see. We need to break. That makes a lot of sense. That makes a lot of sense. Hmm. Oh, that's probably better here. Uh, okay, so here, yeah, there's something fucking crazy happening here. I don't know what. It feels like we're always logging everything for some fucking reason. Even though this is happening. Right? Like, hi. And then we write, like, bye over here. I'm assuming that we're seeing many letters or many losses printed at once for some fucking reason. Yeah, and it's like, what the fuck? Why? After every print, we immediately break outer. Right? Oh, is this in the wrong spot? Is it here? Ah, there it is. Okay, so now we should see that, like, here we're seeing like 195 drop to 102, 90, 102 here, 90 here. Then this should be like 93 is close to 90. This should be a little bit below 64, 79, 78. Then this goes up to 109, back down to 67. Yeah, I mean, I think this is right. I think this is right. So now what we should do is we need to like write that down somewhere. So like the question is who owns like rendering of that thing? We can just write it underneath for now, right? So we just like allocate some space below to write that shit out. Probably. So like label text is going to be a GUI text. I don't remember how this works, but it will become apparent quick. Who is backed by ourselves, right? So haven't figured this one out yet. I've not figured this one out yet. Can we just call like this? No. So this guy, he's going to every once in a while call update on something, and he's going to like retrieve the new data, generate new buffers if he needs to. What does he want? This thing can just be a pointer. Sure. And then he checks if the content matches every frame. Sure. Okay. So here we could like, reasonably just have like label buff here. What do we do for histogram? He had axis text here, which had like an allocation and like a pointer to that allocation. This is a pain in the ass. Ew. Okay, here's what we will do. I've decided. We are going to hold like label buff here somewhere. Label text. So here we want this to be like none of this is easy. None of this is easy. This is a bad. I'm not like the biggest fan of this API, to be honest. What is this guy doing under the hood? A lot. He is doing a lot. Okay, here's what we'll do. We'll do label retriever. We'll say something like this. I haven't figured it out yet. First time seeing Zig. Interesting. It looks quite sophisticated. Could you name a good application to aid it? Yeah, I'm not sure. I don't know if it's like super heavily used. I think the big ones are, yeah, Bun is a big one, and then I think Tiger Beetle people talk about a lot. It's kind of like, it's very like C. I don't think it's like, it's very straightforward by some metric of straightforward, which is nice. Then can this guy just kind of like, dude, why? What is this supposed to look like? We just want to render some text every once in a while and have this guy automatically update it. So this guy's gonna have a pointer to some string. No, he's not. He's gonna have a pointer to a label retriever or something. Does that work? Then this guy is like, yo, this is gonna return this, which was return self buff from 0 self len. That feels like it kind of works. And then I guess when we construct this thing, this graph widget ends up like with a stable address. So we go like label text is undefined, and then we say here like graph widget label text is equal to init. I don't know yet. Hello, GUI. Here we go. Who's gonna live for like the lifetime of the GUI? He is going to use some sort of like widget factory. Where does this come from? GUI state? No, GUI text state. Yep. Okay, we're getting somewhere. And he's going to point to graph widget label text, label retriever or something. Ew, 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 ew. But we will live. This is a bad API. We need to fix this, but it'll do for now. Okay, here we go. We can make this work. We can make this work. Okay, what's he pissed about now? He's like, expected some shit show, found that shit show, forgot to retry. Okay. So now, does this still like run without any problems? Yes, of course, because nothing's happening. So we want to limit the area of the graph so that we leave some space for the text. So here it's like graph bounds is widget bounds, and we say like graph bounds bottom is smaller based on label text size height. There we go. Then we have like label text render given our widget to clip transform, you know, so he kind of comes like this. And then this is wrong. So we have the label bounds here is widget bounds, but the widget bounds top is equal to graph bounds bottom. Nice. Label bounds top. There we go. And so here now our transforms depend on which thing we're rendering. So this is the graph bounds and this is the label bounds here. Okay. Cool. Alt F4. What's up, everybody? Welcome, welcome. I hope you guys had fun over there. What were you working on? We are trying to write a little tensorboard style graph widget for our neural network training framework. Does it compile and run right now? So this is what we got right now. Look at this guy. This is the loss from a short training run, visualized a little bit. We got some lines. We're working on kind of adding like hover text right now. So like where my mouse is over this thing, we want to show underneath like there's some loss, what the value is. So we're just in the middle of adding that. Okay, which means that like every time we move this guy, I guess we do stud format buff print into the label retriever buff with loss is this hype, okay, and then I think we set the len to slice len, okay, and now that should make it so that on every update we should update the graph, the label text. Okay. And we should be somewhere. Okay, get text. Okay, so we're saying text retriever must be a string or have a get text function. Type is label retriever pointer. Oh. What are we working on? Neural network training framework. Right now we're visualizing stats. Visualizing stats for a network that is trying to isolate barcodes from larger images. We've kind of built everything up from scratch. So we're having fun. Okay, so I think that we just need to fix this. This has come up multiple times where our GUI text guy here just needs support to support pointer destruct. So if child info is struct, can we recurse into this? I think that kind of makes this work. What's the goal of finding barcodes? Stop milk from going bad? Yeah, basically. I want to scan things as I put them in my fridge. And then, you know, figure it out from there. What is this piss about? Set input state. Oh. Yeah, I want to scan stuff as I'm putting it in my fridge so that I can track how much of everything I have and then use that. Uh-oh, that's not good. What the fuck? I mean, it's working, but not the way I expected it to. That's so funny. Because we need to adjust our label bounds right to be label bounds dot left plus self GUI label text size width. There we go. That's a lot better. Look at that. Look at that. He's working. He's working. Okay. So maybe we want to center this as well. We might want to like recenter, like center relative to thing, but if it needs a vertical line with the mouse, this feels naked. I agree. So can we do that somehow easily? I was just gonna render a dot, to be honest. I was gonna do like self solid color renderer render yeah, I guess we want like we probably want to like construct a like hover buff. and hover source. And then we can kind of say like, maybe we have like something that's like hover. I guess we can leave this active all the time. And then just say like hovering. Then here it's like hovering is false. Hovering is false. I guess we kind of set this to false unconditionally. And if we find ourselves, we say self-hovering is true here, probably. And then like if self-hovering, we render something here. I don't know what yet. Do we have the height of this thing at this point? We probably need to find that, right? So hovering pause maybe is like you know, something that has I don't really know. Maybe weirdly a pixel bounding box might actually be the right thing to do here. It might be. So here we say hovering pause is null by default. But if we find something, we now have the element here, right? So we have like the value over the steps over the like max value, right? So this is like norm y is this. We have our pixel position x already, so we might be able to be like self hovering pause is like left is I guess we need to like figure out the norm x as well. So this is going to be the step we are on. So this is like iterator over like how many steps are r. Ew. Something like this. So this is going to be like does this need to be this way? I guess we can go the other way. We go like iterator times widget bounds width over the size. This gives me like center x, hover center x or something. When are you gonna buy a GPU rack to run this on? No. Never. I think this is right. Then my hover center y is this times widget bounds calc y or calc height, I think. So this is like where we are relative to the bottom in pixels. This is where we are relative to the left in pixels. And so this is widget bounds left plus hover center x minus, you know, 2 or something. Right is this plus 2. Top is bottom plus this, and bottom is this minus this. Something like this. Something like this. And then we should just be able to like fucking render that shit. So we should be able to be like hover source like this, and we render him like at some location. So transform is going to be GUI util widget transform of self. If we have a hover pause, we use this relative to the window bounds, and he'll figure out how to render there. And color is the same color here. That like might work. Okay, so we just have to quickly make the like hover buff. I think we don't need to store that thing here. So this is gonna be like render XYT program buffer in it, and we're just gonna make like a square here that fills the whole screen, and then use transforms to kind of like move that thing around. So here we can kind of go like v pause is like this, and we're trying to make two triangles here, I think, that make a square. So -1, -1. We want them to be clockwise probably, so it's like this, followed by the same two here, but then the bottom right. So this is like this. I think that's right. We're really playing it fast and loose. But I think it's something like this. Hover source bind data hover buff. I think this is right. I think. I'll be kind of surprised if this works, but only like a little kind of surprised. You know? Oh, it doesn't. Wow. Right. Hovering pause is null by default. Hovering pause. All right. Then hovering pause is covered here. Okay. And this guy's mad because F32, U31. Sure. Ew. Float or int from float on this whole thing. Just absolutely fucking disgusting. Disgusting. Absolutely disgusting, but we're in prototype hack mode, so fuck it. All right. I don't see it. We could try to make this bigger. Okay. Bad news bears. Can we try std debug print rendering at this? How fucked are we? Okay, so this top and bottom feel kind of wrong here. 768 to 804 is like, first of all, the wrong way. And then also feels very large in terms of like the size of this window. So we've kind of fucked something up here. So first of all, let's get these units right. This should be top here. I get confused because like my pixel space is top to bottom, but my other thing is bottom to top. I think it's upside down. I think it's upside down. So this should be bottom minus, actually. Okay, now it's at least following the right shape. But it feels to me like, I think the line is actually wrong. Actually, I think it's like half the height it's supposed to be. Yeah, because we didn't do the times 2 minus 1 here. Okay, so now this thing is following, but it looks fucking stupid because I drew the wrong triangles. But we're close. So this should be, this goes -1, -1, to -1, 1 to 1, 1. So I want this to be negative, negative here. Nice, dude! Alright, cool. And then we just, shrink this motherfucker. It's 10 pixels too large? This doesn't look quite right, huh? Like, what's wrong with it? Its X position feels pretty good to me. Its Y position is kind of fucked. Because the graph is scaled, the graph height is adjusted. So we need a graph bounds from widget bound because the label is part of this thing. Yeah, that's what it is. So we need to be like, it's just this. Boom, boom, boom. And then we use this down here, wherever the fuck we're using widget bounds. Why is everything so hard? Alright, that feels pretty good, right? Yeah! That feels pretty good. And then the loss is shown down here. It's kind of like hard to see, but feels pretty good. Some work is gonna have to be done to support multiple sets of data here. But we're at our like 2-hour mark, so I would say that this feels like reasonably good progress for today. We definitely have work to do. So I think that we come back for a second pass tomorrow, where we go from rendering one graph to rendering many graphs on top of each other. And then maybe, like, I'm not sure what I want to do with this label, right? If we have, like, 5 things in 5 different colors, then we're going to have to figure out, like, how we want to visualize that comparison. Yeah, I'm not sure. So, we'll think about it. What I think we call it there for today. Got a lot done. Thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock now, so anywhere between 3.5 hours ago and now is when you expect to see us live. If you're watching live and you want to keep up with this stuff, but you can't watch us every day live, because, like, why the fuck would you? There's a YouTube link in the Twitch description where, like, feature development goes up. There's kind of, like, we kind of split the stream between feature development and other stuff. Other stuff could be things like reading. It could be things like cleanup and merging. It could be, like, we left the code base in, like, an absolute disaster of a state today. We could spend, the first segment of tomorrow's stream cleaning that up. We probably won't, but we could. So that stuff does not get archived on the YouTube, but it does get archived on Patreon YouTube members or in Twitch VODs. So if you pay in one of those places, you'll get the knowledge that you're helping continue the stream. When I run out of money, I'll stop streaming. And you also get access to the stuff that we don't post. So I think that's all we got to plug. YouTube, peace out, and Twitch, let's find someone to raid.